Greetings and welcome to week 7, unit 3 on instruction for evaluate. In the previous unit, we understood some ways of instruction for analyze activity. We now look at, in this unit, understand how to instruct for evaluate, which is evaluate is the next hierarchically higher level activity than analyze, and to that extent it also represents what you call higher order of learning. Now, what is evaluate in revised Bloom's taxonomy? When we use these words, please bear in mind that we are using it in a very definitive context. We are using the word evaluate strictly as per definition given by revised Bloom's taxonomy, because we are likely to use the word evaluate in a common sense way in several places, which do not necessarily mean only what is defined here. That's where both teachers and students have to be aware of and conscious of, so that you don't make the mistake of using this word in the wrong context. Evaluate involves making judgments based on criteria and standards. You're making some judgments. That is what evaluation is. And it requires students to move beyond simple understanding and application to assess the value, quality, effectiveness, or significance of something. The two sub-processes of evaluate are checking and critiquing. Okay. So, in analysis we had sub-process of differentiate, organize, and attribute. Here we have checking and critiquing. Now, checking, here we understand evaluate activity through these two sub-processes. Checking involves testing, detecting inconsistencies or fallacies within a process or product, and monitoring to ensure quality or adherence to standards. That you are kind of checking, finding out whether something satisfies a given set of criteria. Do the outputs have the performance is within the specified accuracy? Does it get heated up beyond some value? So you have all this kind of requirements for any product or process. You are trying to find out whether it meets that or not. It is primarily focused on verifying that something meets specified criteria or works as intended. Okay. Checking is often more rule-based and objective. No complications. Somebody gives you a set of criteria. You try to find out whether a given product or process satisfies those criteria. To that extent, it will be quite objective. The goal is to identify errors, omissions, or deviations from expectation. Expectations are generally expressed in very clear terms as numbers many times, and you are trying to find out whether you meet those numbers or to what extent you are deviating from them. So the key characteristics of checking include verification of accuracy, correctness, and completeness. Simple. Application of established standards or rules. Many times you don't have to find out which are these criteria that need to be satisfied. There are certain standards to be followed. Standards will very clearly specify this is what it has to be. So, it is objective assessment. Focus on identifying errors, flaws, or deviations. You have to say such and such performance needed to be 0.1%, but it is actually 0.15%. That kind of reporting you have to do. That is what checking is. Let us look at some examples which are performed fairly on a regular basis. Code checking. In any computing exercises, activity students are given a software program, set test cases. The checking task is they check if the program produces the correct output for each test case according to the specified requirements. They might use a debugger to step through the code and verify that it is executing as expected. They document where there are discrepancies and report the test case that lead to it. Okay, that's what the actual checking task. Emphasis is on verifying, validating functional correctness against a defined specification. That's what the code checking is. Another example related to circuit simulation verification. Activity students design a circuit and simulate its performance using software. Checking task, they check if the simulation results match the design specifications in terms of, let's say, voltage levels, currents, current draw, frequency response, and so on. If the results deviate from the expectations, they investigate the circuit design and simulation setup to identify errors. Emphasis on verifying that the simulated circuit behavior conforms to the intended design. These are two examples taken from computing area and the electronics. Now coming to critiquing. Critiquing involves making judgments about the value, relevance, or effectiveness of a process or product based on reasoned analysis. It is not exactly like measuring some value, temperature, current value, voltage value like that alone, but based on some information provided to you, you are making a judgment. It goes beyond simply checking for errors and involves forming an opinion based on informed judgment and criteria. We will look at examples. In every case, it is not just checking against standards or measuring something. There is a lot of information that is provided and functional and non-functional performance of something, and then you have to put it all together and make a judgment. The key characteristics of critiquing: subjective assessment of quality, worth, or significance. There is some subjective aspect in terms of critiquing. It is not like the checking, which is dominantly or mostly objective verification. Application of judgment and expertise. Consideration of multiple perspectives or factors. Because if you look at some system from one perspective, it may be acceptable. From another perspective, it is not acceptable. Like often happens when you look at, let us say, you are designing a storm water drain design. It may not be acceptable from, let us say, pedestrian point of view. It may perform its task, but it is not acceptable from a pedestrian point of view, or it occupies too much of space which you don't have, and so on. So there are multiple perspectives or factors are involved, and you have to make judgment based on that. Forming an opinion or making a recommendation based on analysis. So you are forming an opinion and you are also making a recommendation at the end of critiquing process. Now an example of critiquing: a design evaluation. Students are presented with a proposed design for a bridge. Okay, complete design of the bridge is presented. Critiquing tasks, they critique the design for structural integrity, that is safety, aesthetics, visual appeal, which can be subjective, environmental impact, cost effectiveness, and sustainability. In many of these dimensions, you have multiple perspectives can come in. The emphasis is on forming a judgment about the overall value and suitability of the design based on multiple criteria, some of which may be subjective. Okay, that's what we are trying to say. Here in the end, you have to still make a judgment that the design is acceptable. You cannot say, no, according to this perspective, this is not desirable. If necessary, you have to modify the design, but somewhere you have to draw a line and say this is acceptable. Now, another example of critiquing tasks, students must critique the building design from a sustainability perspective using a holistic approach. They need to address the following points and develop a justified opinion: environmental impact, economic viability, social equity, life cycle, trade-offs and conflicts, alternate solutions. So, if you do this kind of exercise, the students get now a much, what do you call, a detailed view of engineering activity. If it is strictly according to one textbook, solving a particular problem, applying certain formulae, if you restrict yourself to that kind of activity, yes, you have some skills, but you cannot perform all the activities that an engineer needs to perform. Okay. I am repeatedly saying that because that is generally what is missing in many of the programs that are offered in India. General strategies for evaluation. Now we look at evaluation as both checking and critiquing. Criteria based assessment, that we mentioned what it is. Justification and reasoning. Students must provide clear and logical justification for their evaluations. You cannot merely say, I don't like it. Okay. Supporting their claims with evidence. Critical thinking, encourage students to consider multiple perspectives and potential biases. Real world relevance, connect evaluation activities to realistic engineering scenarios. These are the general strategies that one needs to follow. Now let us look at the general principles for instruction for checking, a little more specific with regard to each sub-process. Clear standards. The most important thing is to provide students with a very clear and specific standards, criteria or rules that they must check against. Okay. They must be provided with the standards. Whatever codes that you have in civil engineering or in mechanical engineering, you have certain professional requirements. Those should be presented to, details should be presented to the students. Focus on accuracy. Emphasize the importance of accuracy and attention to detail. Checking is about finding deviations. Even small errors can have significant consequences. So you cannot say out of 10 factors it satisfies 9 factors, it's okay, because you are looking at it on a piece of paper. But as an engineer, you have to really look at the significance. Is there a difference between 0.1% accuracy to 0.2% accuracy? It looks like a small number, but what kind of implication does it have? Okay. Systematic approach. Encourage students to develop a systematic approach to checking to ensure that they don't miss anything. See, the engineering activity is paying attention to detail. No detail is unimportant. As I said, I am looking at out of 10 factors, 8 factors are met. You look at as a student, say that you give me 80% marks kind of thing. That kind of thing will not do with regard to engineering activity. Product will fail. Tools and techniques, equip students with the necessary tools and techniques, and in fact background information as well, to perform the checking tasks effectively. Okay. So these are specific instruction strategies. Not all of them need to be followed, but these are possible strategies. Provide checklists, develop rubrics, model the checking process, demonstrate how to perform checking tasks step by step. You can actually, teacher can present one example talking loud on each step, and provide examples of correct and incorrect work. Use error detection exercises, implement peer review, use automated checking tools if you have. Some software tools are available for certain activities. Provide feedback on checking performance. That is very important. Students should be told what went wrong or what went right. Encourage a culture of accuracy. Engineers have to be concerned with accuracies. That is not a secondary part. Provide practice opportunities. So these are all the specific instructional strategies can be considered for promoting or facilitating checking. Now coming to critiquing, the general principles we will first talk about. Clear criteria but flexible application. Provide students with criteria to guide their evaluation, but emphasize that these are guidelines, not rigid rules. Good critique often involves questioning or even redefining the criteria themselves. Multiple perspectives. Encourage students to consider different viewpoints and stakeholders. Because for every product or process, every design that you have, multiple stakeholders involved. Each one has their own perspective. So are you able to consider those perspectives? Balanced assessment. Emphasize the importance of identifying both strengths and weaknesses. Justification and evidence. Require students to support their judgments with clear evidence and reasoned arguments. Constructive feedback. Focus on providing constructive feedback that can help improve the object being critiqued. So these are broadly the general principles. And now you can talk about specific instructional strategies. Establish evaluation frameworks. Provide students with a structured format for writing the critique. It is possible to give it, then it becomes easier. Each student doesn't have to discover or invent his own format for presenting his critique. Model critical thinking. Teach them how to identify logical fallacies. Example, ad hominem attacks, straw man arguments, or how to assess the reliability of sources. See, these are some of there are some logical fallacies people keep committing. You find a non-existing issue and keep talking about saying that is not met, it is not done. Generally, the straw man arguments are used heavily by politicians. That is, you shift some hypothetical issue and then keep focusing on it. Promote perspective taking. Encourage students to consider different viewpoints and stakeholders when evaluating an object or design. Facilitate debate and discussion. Use case studies. Provide opportunities for peer review. Emphasize justification and evidence. Encourage creativity and innovation. reflective practice. If you look at specific instructional strategies, there are many things that are common to checking also. Okay. The key is to emphasize reasoned judgment, evidence-based arguments, and the consideration of multiple perspectives. These three are the most important issues of critiquing. In summary, emphasizing evaluation experiences in undergraduate engineering programs is essential for developing well-rounded engineers who possess critical thinking skills, problem-solving abilities, decision-making capabilities, communication skills, ethical awareness. As you can see by the words themselves, you can ethical awareness PO6, communication skills PO9, and problem solving abilities, they will all be PO1 and PO3 and so on. Critical thinking skills, again they address many POs. They are needed to succeed in a complex and rapidly changing world. It prepares them not just to apply existing knowledge, but to create new knowledge and make responsible, impactful contributions to society. And if you look at this, for example, critical thinking skills. So, as I already mentioned, you cannot offer a course on critical thinking once expert comes and gives that. It doesn't make students necessarily able to critically think. It has to be infused into as many courses as possible. And how do you infuse critical thinking into a course? By incorporating activities related to evaluate. We have seen that. It can also be activities related to analysis as well, can promote critical thinking. So you have to design your course consciously to make sure that where exactly you are promoting any of these activities. Okay. So I've been repeating this. So it requires a considerable effort on the part of teacher to design such a course. And in the next unit, we will look at instruction for communication. Communication is a very important one, as we have already seen, both in analysis as well as in evaluate. And we will now focus on communication, which is also represents PO9, program outcome 9. And thank you for your attention.